We today are going to start doing radicals. So at the top of your journal page, I'm going to title it Radicals. If you remember correctly, this would be something you covered in Algebra 1, so this is really just a review. So the first thing I want to talk about with radicals is adding and subtracting. So I'm just going to title this Addition and Subtraction right over here. And I want to make a comparison to something you definitely already know. So I'm going to kind of just draw a line right down the middle. All right. In algebra, you would have started with something like 2x plus 1x. And that would equal a total of 2 plus 1 is 3x's. All right. The equivalent here is if I have 2 square root of 2 plus square root of 2, this is equal to 3 square root of 2. I don't add what's inside. These are just like the x's we did over here. Again, I have 3x plus 4x. So how many x's total? 7 x's. 3 square root of 3 plus 4 square root of 3 equals 7 square roots of 3. Again, the square root of 3 behaves like an x. If I have 2x plus 1x plus 3y, then when I add like terms, my x's add together for 3x plus 3y. But I can't go farther than this because they're not the same letter. So again, if I had 2 square root of 2 plus 1 square root of 2 plus 3 square roots of 3, these all behave like letters, x, x, and y. That'll give me 3 square root of 2 plus 3 square root of 3. All right, so we want to just make sure we're kind of watching that. Remember, it could be square root of 2, square root of 6, square root of 7, doesn't matter, but the square roots behave like letters when we have addition and subtraction. Multiplication. All right, so here's our multiplication examples. When I start with square root of 2 times the square root of 2, this is now no longer like addition. I actually go inside. I get the square root of 4. And I simplify the square root of 4 is 2. If I take square root of 3 times square root of 3, I get the square root of 9. The square root of 9 is 3. Square root of 2 times the square root of 3 equals the square root of 6. I can go no farther. There is no square root, so that is my final answer. Now, looking back up here, I'm hoping that you're catching on that when you multiply 2 square roots together, you just pull the number out. This is really like saying the square root of 2 squared is equal to those times those, and then getting 2 out. Same thing down here. Square root of 3 squared, break it out, okay, just pull the number out. And that's something to really pay attention to. Now, doing something a little bit harder, we have 3 square root of 3 squared. Now, in my head, I already know this is 27 because I've done this a long time. But if you're having trouble seeing it, then first you expand it out. 3 times the square root of 3 times 3 square root of 3. The outside numbers multiply together, 9, and the inside numbers multiply together, square root of 9. The square root of 9 is 3, so 9 times 3 is 27. The goal is to eventually be able to do that in your head without writing down those steps. Division. All right, and just something simple, square root of 6 divided by the square root of 2. Since you're inside, they're both numbers, there's nothing else going on. 6 divided by 2 is 3, so it is the square root of 3 is your final answer. If you have something like 4 square root of 2 over square root of 2, okay, those cross out. You cannot use that 2 to go into 4 somehow. So yes, those go away and you just get the 4. You cannot go in and out of square roots unless you're multiplying or dividing. They are their own thing, and when you're not sure, replace square roots with letters and they behave just the same way. 4x divided by x is 4. Now, once we finish radicals, and those are our reminders about our rules, let's look specifically at simplifying radicals. So at the top of my paper, I'm going to start by writing simplifying radicals. And I'm actually going to draw a line down the middle of my journal. And I'm going to title this in my head versus with help, meaning I have to show some work to get there, and that is okay. Okay, so I have in my head versus with help. So, starting with something simple, square root of 4. Square root of 4 is 2. Now, if I'm not sure, I can come over here and I think, okay, what things multiply to 4? 2 and 2. These are both primes. Now, I can move partners out of my square root. So I circle the partners. They're out of the square root. That gives me 2. Let's look at the next one. Square root of 27. This is 3 square root of 3. But what if I don't know how to do that in my head yet? Well, I'm going to come over here and I think of what multiplies to 27. I have 9 and I have 3. 3 is prime, 9 is not. I have 3 and 3. These are now primes. Partners leave the house, and the partner can actually be right over here. So they left. Who stayed behind? That guy right there. Same answer, just a little bit of work. Let's look at square root of 32. This is going to be 4 square root of 2. Now, I want you to kind of stop now and think about what could make my world easier. Well, the first thing that can make your world easier is know your squares. If you know your squares, you will be able to do this even faster and in your head. You have 1, 2, you have 4, 9, 16, 25, 36, 49, 64, and going on up. Okay, so 1 squared is that, 2 squared is 4, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. All right, and it goes on and on. So when I look at square root of 32, I know that the square that lives in there is 16 times 2. Well, the square root of 16 is 4. 2 gets left behind. I'm done. I can do this in my head. I don't have to write this down. That's how I do this. Now, if you still don't see that, then your work may look like this. 4 times 8, none of them are prime. 2 times 2, primes. 4 times 2, prime. 2 and 2, primes. Pairs leave the house. 2 times 2, 2 gets left behind. 2 times 2 is a number, 4 square root of 2. Okay? Now we're going to go down and do square root of 75. In my head, I know that that's 5 square root of 3. So square root of 75. Go through. Are there any perfect squares that live in there? Actually, 25 does. So 25 and 3. Square root of 25 is 5. 3 gets left behind. Notice now, I'm stepping away from doing this because hopefully I'm going to start getting better. Okay? The last thing that we want to talk about is estimating. Sorry, let me rip this off. All right, so on estimating, if I wanted to estimate the square root of 80, because I want you to remember, this is the most exact answer we have, square root of 80. There's been no rounding for decimals or anything. So I think of my squares, and I think, okay, 8 squared, if I have the square root of 64, that's below it. 9 squared brings me right above this. Okay, so the square root of 64 is 8. Square root of 81 is 9. If I'm at the square root of 80, I have to be closer to this one. So if I was on a SAT or ACT test and I was having to guess off a number, I would be guessing 9, but if I needed some decimals, I would be using maybe something like 8.9 almost, because that is that close to 81. So my value would be 8 is less than or equal to x less than or equal to 9. To tell anybody looking at my paper that the value of square root of 80 will be in between those values. All right, best of luck with your radicals. This should look very familiar from Algebra 1. Have fun!